The topic for this video is chemical reactions. The essential questions are: what is the law of conservation of energy? How does that apply to chemical reaction equations? And how do you balance a chemical reaction? So the law of conservation of mass says that matter cannot be created or destroyed. So what this means for us when we're writing equations is that the reactant mass has to equal the product mass. It can't just disappear. So that also means that the number of each type of atom has to be the same on either side of the arrow. So I'm going to show you how to balance an equation, and we've already gone through and written good formulas. So we have H2 plus O2 makes H2O. Okay, and we cannot change those subscripts, which are the little numbers there, because we have good formulas. So what we can do is add what's called a coefficient. So I'm going to show you the process of doing this. So the first thing I'm going to do is I'm going to divide up reactants and products, and it's going to be everything on one side of the arrow versus everything on the other side of the arrow. So first I'm going to count my hydrogens. So on the left I have H2, so that means that there's 2 hydrogens there. On the right I also have H2, which means there's 2 hydrogens there. Okay, so then on the oxygen, on the left we have O2, so that means there's 2 oxygens there. But on the right it only says O, so that means we only have 1 oxygen there. So what we need is for each type to be equal on either side. So our hydrogens are good, but our oxygens are not. So I can add what's called a coefficient. And I need more on the product side, so I'm going to add the coefficient there. And it's a big number that goes in front, and it means that you have 2 of the entire molecule. Okay, so now I'm going to recount. So that means there's 2 H2Os. So that means there's 2 O's. So it's going to change. So now that matches, and that's good. But it also means that there's 2 sets of 2 H's. You can just multiply those. So 2 sets of 2 gives me 4 hydrogens. Okay, so now my hydrogens don't match, and I need everything to match before I'm done. So if I look back on the other side, the hydrogen and the oxygen are separate, so I can just add a coefficient to the hydrogen portion. So if I add a hydrogen there, that's 2 sets of 2 H's, which gives me 4. So now I have 4 hydrogens on either side and 2 oxygens on either side, and I have a balanced equation. Okay, let's look at another one. Okay, so again, I've written my equation with good formulas, so now I can't touch those subscript numbers anymore. So I'm going to make a chart, reactants and products, and I'm going to start with Mg. Okay, so on the left I have 1. On the right it says MgCl2, that's just 1 magnesium. So again, those match, that's good. Okay, I'm going to do my chlorines next. One rule of thumb I would use is to do hydrogens and oxygens last most of the time, because a lot of times they'll kind of work themselves out when you have worked out everything else. So if I look on the left, I have 1 chlorine, and on the right I have 2, and that's going to be a problem. Okay, but we'll come back to that in a minute. Let's count our H's first. I have 1 hydrogen on the left, and I have 2 hydrogens on the right, and again, that's also a problem. So if I look at this, remember when I add coefficients, it's going to affect the entire molecule I add it to. I can add 1 right here, and that's going to give me 2 HCl's. So what that does is gives me 2 Cl's and 2 H's. So that's all I had to do to fix that. And now I have equal reactants and equal products on both sides. Okay, we're going to go through these a little bit quicker. You can still make a chart if that helps you. So here is the one we actually just did, Mg plus HCl. And so I can just go through this in my head. I have 1 Mg on the left, 1 Mg on the right. I have 1 H on the left and 2 H's on the right. So I'm going to add a 2. Okay, now I have 2 H's left and 2 H's right, so let's keep going. That gives me 2 Cl's on the left and 2 Cl's on the right, so that one's done. But we just did that one, so let me show you a new one. H2 plus N2 makes ammonia, which is NH3. So I'm going to start on the left. It tells me I have 2 H's on the left. I have 3 H's on the right. Okay, so I'm going to need to fix that. But really, it makes it easier to go to 6, because I can't break that into portions. Okay, so I'm going to have to go to the lowest common denominator, which is 6. So 2 sets of 3 gives me 6. And if I go back here, 3 sets of 2 on the hydrogens give me 6. Then if I check my N's, I have 2 N's on the left and I have 2 N's on the right because of that coefficient. So I'm set. If I looked at the next one, I have KClO3 yields KCl plus O2. So I count 1 K on the left, 1 K on the right, that's good. 1 Cl on the left, 1 Cl on the right, that's good. 3 oxygen on the left and 2 on the right. So I'm going to have to fix that, and remember those come in sets, so I can't break that up. So I have a set of 3 and a set of 2, so my lowest number is going to be 6. That means I can add a 2 over here. That's going to give me 2 sets of 3 on the oxygen. Okay, but that also, we'll fix oxygen first. That's going to give me 3 sets of 2 on the oxygen there. So I have 6 oxygen, 6 oxygen. But that messed up my Ks and my Cls. Now I have 2 Ks and 2 Cls on the left and only 1 of each on the right. So I'm going to need to add a 2 right there. And I have 2 Ks and 2 Ks, 2 Cls and 2 Cls, 6 oxygen, so I'm set. Okay, let's look at the next one. Al plus CuSO4 yields Cu plus Al2 plus SO4, 3. Okay, so I'll go through each of these individually. I have 1 Al on the left, and I have 2 on the right, so I'm going to need to add a 2 in front. Okay, so now my Als are even. I have 1 Cu on the left and 1 Cu on the right, so that's okay right now. I have 1 S on the left and 3 S's on the right. Remember, if the parentheses, the number outside the parentheses applies to each part, so I have 3 S's there. So what I'm going to need to do is put a 3 in front to give me 3 S's over here. And then if I check my oxygens, that's going to give me 3 sets of 4 on the left, so that's 12. And I have 3 sets of 4 on the left from the 3 outside the parentheses, so that's 12. So now that's all good, but I've messed up my coppers. I have 3 Cu now on the left and only 1 on the right, so I'm going to need to add that in. Alright, last one. Ag3PO4 plus BaOH2 makes Ba3PO4 2 plus AgOH. So let's start at the beginning. I have 3 silvers, and I only have 1 on the right. So I'm going to want to change that, but I'll come back to that in a minute. If I look at the PO4s, I have 1 PO4, and I'm just going to treat it all as one thing because it doesn't break apart here. So I have 1 PO4 here, and I have 2 on the right. So I'm going to put a 2 in front, okay? And that's going to change my silvers a little bit because I have now 2 sets of 3 silvers, and I have 6 over here and 1 on the other side. Okay, so the next thing I want to do is put a 6 to fix my silvers. So now I'm going to want to check my bariums, and I have 1 on the left, 1 Ba, and 3 Bas on the right. So I need to fix that. So I need to put a 3 there, and then I'm going to check so now my silvers are good, my Ags, my PO4s are good, my Bas are good. I need to check my OHs. I have 3 sets of 2 OHs on the left, and I have 6 OHs on the right. That's 6 and 6, so that's good.